we'll try to prove, or we are try to apply the sandwich theorem for the original one. So here x, I will take n alpha, and I am writing that original sequence by using this x minus integer part is always lies between 0 to 1 because it is, so this is strictly less than 1 because it is the fractional part. So from here we can write 0 is less or equal to n alpha. If you subtract the integer part of n alpha from n alpha, you will get the fractional part, which is always lies between 0 to 1. We need here n alpha by n, so if you divide by n, what you will get? So here division by n, so 1 by n. So this side is 0. So here I am putting equality because this can be less than 1, so definitely it will be less or so this equality I cannot put here. This is alpha minus this divided by n, 1 by n. So if we apply the sandwich theorem, this side is going to 0, this side is also going to 0, so this sequence will also going to 0 because the middle sequence is greater or equal to 0 but less than 0, so it must be 0 only. So from here we can conclude that the sequence n alpha by alpha will converge to alpha only. So this sequence will goes to alpha. And before applying the sandwich theorem, you can also find this, then you subtract alpha both side, and then also you can apply the limit, then left and right hand side both are going to alpha, so the original sequence will also goes to alpha. So up to this, in this example, anyone have any doubt? Tell me, I will repeat what I did if you have doubt.
Then question, it is greatest integer or fractional part?
See, it is the greatest integer. This is the integer part of that n alpha. Whatever n alpha will come, that integer part of that. Okay. So now the next question, give me a sequence, rational sequence, which will converge to the rational number. That means all the terms of the sequence would be rational and the limit will also be the rational number. Can you give me one sequence which will converge to the rational and the sequence is also rational?
N alpha.
Four question. So rational sequence, it will converge to the rational also. Its limit will be either rational or irrational. So we will discuss both the example. Sequence is rational and its limit is either rational or irrational. What will be the example in both the case? Then the second one is the sequence is irrational, and but limit is either rational or irrational. So total 4 questions. So first we will deal rational sequence. Give me a sequence which have the rational, but its limit is also rational. Then the another example, sequence is rational, but limit is irrational. And the second type, then again there are 2 parts. Here the sequence is irrational, but limit is either rational or irrational. So we need 4 examples. So first we'll do this number 2 and then we'll go back to the number 1. Give me a irrational sequence which will converge to the rational number.
1 by root n.
1 by root n. What is the limit of 1 by root n? 0.
0.
Yeah, so this is a irrational sequence. It is converging to rational. Then give me the irrational sequence which will converge to irrational number. Yeah, let me write.
Yes.
Yeah, 1 by
root n plus root 3.
Plus root 3. So it will converge to root 3. So like that you can give the example. So I am giving the general example. The general example is alpha plus So I'm here writing square root 2. You can write anything divided by n. So this will converge to which number? Like limit n tends to infinity, it will goes to
Alpha.
alpha. So it is
Alpha.
yeah. So it is a real sequence or a rational sequence or irrational sequence?
Irrational.
Irrational. All terms of this sequence are irrational because of root 2. Okay, it will always goes to alpha.
Yes.
If alpha is the rational number, you will choose. Suppose alpha equal to 1, it will goes to 1. If you take alpha equal to half, it will goes to half. If you take alpha equal to pi, it will goes to pi. So this is the answer of both the question. Depending on the alpha. If alpha is the rational, it will goes to rational number. If alpha is the irrational, it will goes to irrational number. So this is a irrational sequence which will converge to the alpha depending on alpha is the rational or irrational. So now go back to this question. So rational sequence converging to irrational number. Sequence is rational but limit is irrational. So I am giving example alpha plus 1 by n. What is the limit of this sequence? It is alpha.
Yes.
If alpha is irrational number, so is it rational sequence or irrational sequence? I need a rational sequence which will goes to irrational number. Can we take this example? Yes or
But
no?
it is irrational.
Yes.
No, sir.
Yeah, we cannot take example because if alpha is equal to root 2, the sequence will become itself irrational. We need a rational sequence. So this is not the correct example. So the correct example is this one. If this sequence is rational, this one means this one. The above part is also integer, below is n and is also natural number. It is integer by integer. It is a rational number. It is going to alpha. I already gave the proof. So the correct answer is n alpha integer part or box of n alpha divided by n goes to alpha. So the correct answer is n alpha integer part divided by n. So this sequence is a rational sequence. If alpha is a real number, alpha is a rational number, it will goes to rational. If alpha is a rational number, it is going to irrational. So this is the example of a sequence which is a rational, but its limit can be rational or irrational. It's depending on the alpha. If you choose alpha equal to root 2, it will go to root 2. If you choose alpha equal to pi, it will go to pi. If you take any irrational number, it will go to that irrational number. If alpha equal to half, it will go to half. So I hope it is clear to everyone. Like I give 4 example. So whatever alpha plus 1 by n is written, that is the example of a rational sequence goes to rational. But this example is work for both the cases. Depending on alpha, what alpha you will choose, it will go to accordingly that number. So now the next topic is the series. So let me first define what is the series. Infinite series, I am saying infinite series in real number is the expression of this form, like x1 plus x2 plus x3 and so on up to infinite, where xn is the sequence in R. You know what is the sequence. So such type of expression is called infinite series. So I'm just giving one example of this. So the first term is 1 because this is the sequence in real. So I'm giving x1 is 1, then minus half plus 1 by 3 minus 1 by 4. So this is the example of a series or not? Like x1 value is 1, x2 value is minus half, x3 is 1 by 3, x4 is minus 1 by 4 and so on. So this is the example of series, yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
So
sir.
this is
Yes, sir.
the series. So now someone is saying limit, last term, whatever now you are saying, now tell me what is the meaning of series is convergent.
When the sum is convergent.
Sum is convergent means what?
When its sum is
Sir, we
not
have to find
infinite.
the nth term.
We have
Sum
to
is
find the
finite.
So
nth
when
term. Sum is
summation,
finite.
When the
when the
sum is finite.
summation of the series finite.
So can you tell me what is the sum
Sir,
of this
when the
series? Whatever I wrote. Yeah, someone is saying find the nth term also. Yeah, someone want to say something else? Please tell.
sir, when
Ln
the
2,
limit
ln
and
Yeah, log something someone is saying.
LN2.
ln2.
Yes, sir, LN2.
Okay. So how you are saying it is ln2?
Sir,
It is
ln1 plus x
it
plus
satisfies in the form
1
of
plus
log series of log.
Okay, this
The
is a series
expansion
of
of
log.
MA1 plus
Yes, this is a series of log 1 plus x.
putting
If you
x
put x
equal
equal
to
to 1, you will get ln2.
yes, sir.
So for any series, is convergent and this divergent is required or not? I will tell. Okay, so the actual definition of the convergent of series is that if series have a finite sum, not an infinite, any finite number, if the summation of n from 1 to infinite this xn, if it is finite, then we'll say the series is convergent. That means if we have the finite sum, like for this example, this sum is ln2, that is some number, finite number, not an infinite number, ln2. So this sequence, this series is convergent. I will give the actual definition, means mathematical definition, when you will say the series is convergent also. Yeah, someone is saying another term will also say some information about the series, that also we'll see. So let me do here something. So what I am going to do, I am just keeping the all positive term like 1 by 3, 1 by 4, no, sorry, 1 by 5, and then all negative terms. I'm just doing something here, and so on. These are all positive terms in the series, then all negative terms will subtract. Minus 1 by 2, 1 by 4, these are all even term, 1 by 6, and so on. So from the first expression I got 1 plus 1 by 3, 1 by 7, 1 1 by 5. That's now 9 before. So now what I'm going to do here, I am just adding here 1 by 2. I am adding 1 by 4 also. In this bracket I added some terms. I added 1 by 2, I added 1 by 4, 1 by 6, and so on. So whatever term, extra term I added, I will subtract those term also. So I am subtracting those term. It is already subtracted 1 times. So here 1 by 2, 1 by 4, and so on. So it is 2 times this. Is it okay to everyone? I added 1 by 2, 1 by 4, that, and I subtracted also the
Yes,
same.
sir.
Yes,
So
sir.
now I will multiply 2 in this expression. So once you will multiply, what you will get?
1 plus
The same.
1 plus 1 by 2 plus 1 by 3.
That
Yeah,
same
this is
series.
as it is. Yeah, here you will get the same series, 1 plus 1 by 2 plus 1 by 3. This one is same, and here also you will get 1 plus 1 by 2. So we'll get answer 0. That is the value of ln2. So if you to take this is the e to the power 0, that is nothing but 1. So this proves that 2 equal to 1. That means something is wrong. So can anyone tell what mistake I did? Or what property I used here which is not applicable in the series, but I did here
So
in
what
the
did you do
calculation.
in while going from second to third step?
Second to third step. See here I subtracted all positive term and all negative term. Then here I added 1 by 2, then I have to subtract also minus 1 by 2. So 1 by 2 minus 1 by 2. So I added 1 by 2, 1 by 4, 1 by 6 here in this. The same I subtracted. So 1 minus 1 by 2, previously it was there, and I again subtracted. So it becomes 2 times minus 1 by 2. Yes.
Sir,
Excuse me, you did
sir, first you
infinity minus
assume that
infinity.
infinite.
I did infinity minus infinity. So where is the infinity?
Yes, sir, that first
The
term.
sigma 1 over n, that one, sir.
Excuse me,
Yes.
sir.
This is infinity. Yes.
Sir, I am giving a question that will solve the answer of this. I mean, I want to say that I am giving a question like similar to this. So, if you do like this, you will get 0, but the actual answer is not 0.
Yeah.
So shall I? Sir, do 1
No.
minus 1 plus 1
No, I
minus 1
agree.
dot dot
Yeah,
dot
yeah.
dot.
Yes, I understood your logic. I'm
Yeah.
saying what is wrong here. Yeah, definitely it will give not a correct
Sir,
answer. Yes.
So you
infinity
cannot, I think,
sir, first
multiply
you assume that
two infinite sum of infinite numbers. Like you write in second last step, there is a mistake in second last step.
Yeah, definitely. I can definitely say what I can say. This is wrong. This I can say. This is also wrong. That I definitely I can say. That means from which step it is wrong. That's why all are wrong. That
Sir,
step
we
I
don't
want
know
to.
the last.
So
Can
that
you
a
cancel?
multiplication of the two.
sir,
Second last
fourth
step, sir.
number.
Minus
Fourth
2
number,
Sir, I think
into 1 by
So
2 plus
second
something.
step.
Sir, can I say,
Second
sir?
step.
Yes.
Sir,
Say.
actually, this series will end at some point, no, sir. So, if
Yeah,
that
sir, it
series
will not
ends
contain the exact
with
same terms.
denominator even or the denominator odd, then one term will be, we will lose one term now.
We will never lose any term. All terms I did. Then that's why LN2 came without losing any term.
No, sir. Actually, this series will end something like 1 by 2n or something like 1 by 2n plus 1 at 1 by 2n or 1 by 2n plus 1.
Yes.
The
So what is
last
the problem?
term should be, but here
There is
we
a.
will
Yes. Yes.
Sir, there in the fourth step,
Sir,
those two brackets will not be equal.
sir, in
These
last step,
two are not equal
first
anyway.
first sequence is double number and second sequence is half number.
Yeah. So what is the
We don't
problem?
have same number of points in last one.
Yes. Same.
Sir, there is no mistake in this sequence addition. Mistake in LN2 finding, sir.
Okay. Someone is saying this is equally wrong. It cannot be LN2 also.
Yes, sir.
Okay. So I will answer not now this. We'll see this answer also. I will tell that correct answer what mistake is here. So we cannot do whatever we want in the series. That is the one thing. Like whenever we want something, we cannot do. Like we can see what I did. I just grouped the terms. Like I put this bracket, I put positive terms one side, negative term. This is called grouping. Okay, some terms also I rearrange. So the question is that is rearrangement is possible in the series? Is we can group the grouping is possible in the series? Can we group the series like term of the series? So these question will answer. Okay, then I will tell the mistake what definitely it is wrong because 1 cannot be equal to 2. Okay, some convergence related issue if there, then also we'll see. So first we will discuss what actual thing like what is the convergence divergence, and then I will come back to this particular example also. So for the timing I'm leaving why it is wrong and what is wrong. So in the series there are two term that popular things is one is the nth term of the series. Like first term x1, second term x2, then what will be the value of the nth term of this. Okay, another one is Sn. So here an xn is denoted by the nth term of the series. So for this example whatever I wrote this series, can anyone tell what will be the nth term of the sequence? Nth term, like first term is 1, second term is minus half, third term is 1 by 3.
Plus 1 to the
So
power
what
n plus 1 by n.
minus 1 की power n
minus
into 1 by n.
Minus 1.
so we cannot tell. Sir.
minus 1 to the power
yeah,
n
we
it's
can
minus
tell.
2
Raised to
into
power
1
n
by n.
minus 1.
Yeah, we can tell. Someone is saying we cannot tell, we can tell.
Minus 1 to the
Sir,
power
Minus
minus 1 to the
Minus
power
1 to the power
One
n by
minute, one minute.
n.
Summation
Minus
of
1 to the
minus
power
1 to
n.
the power n minus
No, there is no summation. It is
into
nth term, only one term. There is no summation at all.
Minus 1 to n by n. By
1 by
By
n.
n.
n plus 1.
So let us check it is correct
Yes,
or
sir.
not. If you put
minus 1 to
any,
the n
Sir,
minus
so
one.
minus 1 raised to n
the
minus
n
1.
minus
Power
1
power.
n
Yes,
minus
sir.
1.
Minus 1.
see, I am writing all minus 1 to the power n plus 1 divided.
Yes,
Divided
sir.
by n.
Divided by n.
divided
Divided
by
by n.
n.
I am writing minus 1 to the power n minus 1 divided by correct. Just yeah, yeah,
N belongs to capital N.
Check if you put n equal to 1, you will get the value of x1, the first term. If you put n equal to 2, you will get the second term. Like here, if you put n equal to 1, the answer will come 1. If you put n equal to 2, the answer will come minus half, then 1 by 3 minus 1 by 4. So if it will come, then it will be that this will is the another term. So if you put n equal to 1 here, you will get minus 1 by 1, that is minus 1. So this is definitely wrong answer. Minus 1 to the power n, this is not the correct answer.
So put a negative sign.
This is not the correct answer. Okay. So now if you put n equal to 1 in this, what you will get? N equal to 1. You will get minus 1 square
1, sir.
divided 1. Okay, so the first term is matching.
1.
Now put n equal to 2. If you put, the value of x2 will come minus half. Minus 1 by 2.
Minus.
Yeah, minus 1 by 2. Then you will get plus 1 by 3. So this is
Yes,
the correct nth term. What about the this one? The third one.
Shanks.
That one also correct, sir.
Correct,
So
sir.
that one is also
Both
Yes,
correct. So
sir.
these
are
both
same.
are, yeah, both are same.
Yes,
The
sir.
only
Both
written in
of
the
these are
different format.
Yes.
Both are same actually. It is written in some different format. That's all. But that is the nth term. Okay. Now here it is written nth partial sum of the series. So what does it mean? Okay. So the Sn is the nth partial sum. That means it is the sum of first n term of the series. Not all term, first n term. Like this is up to xn. That is the meaning of Sn. Like if it is S1, it is only first term. If it is S2, it is the sum of first two terms, sum of first two terms, S2. If it is S10, that means first 10 terms of the series. If you add whatever you will get, that will be S10. So Sn is the nth partial sum of the series. That means you are adding first n terms of the series. Whatever sum will come, that is Sn. So I think Xn and Sn
Sir,
both are clear. Yes.
sir, why it is
Yes.
partial sum, sir? When you are giving Sn, sir,
Partial.
the
Yeah.
total nth
Why
term.
it is? Yeah. Why it is partial sum? Because all terms here are infinite term. We are not adding all the terms. We are adding only partial sum. That's why the name is partial sum. Like if you are taking two terms only, not all terms, then it is S2. If you are taking 10 terms, it is S10. That's why it is partial sum, not complete sum. Complete sum will be n from 1 to infinite.
Okay, sir.
So for every series, you can find two things. One is xn, that is the nth term, very much important. We'll see in later class also. And xn is the nth partial sum, that means the sum of first n terms of the series. So this Sn have this Sn is actually a sequence. Like if you will write from n equal to 1 to infinity, that means this is a sequence. Like first term is x1, second term is x1 plus x2, third term is x1 plus x2 plus x3. Similarly, another term, even if you put infinity, then what you will get? S infinity will be what?
Sum of the series.
Yeah, that is the actual
Sum
series,
of
the
the
sum of the
series.
series. So the limit of this sequence Sn is the sum of the series. Can I say the limit n tends to infinity, whatever Sn we will get, that is exactly the sum of the series. So if this sequence is convergent, we will say series is convergent. Whatever limit it will come, that is the sum of the series. So that is the definition of the convergent of a series in terms of the sequence. And that sequence is nothing but the nth partial sum. So the convergent Xn, the series is convergent if Sn will converge. Like if the sequence Sn will converge, then we'll say that the series is convergent. And if you able to find the limit of this sequence Sn, that is nothing but this sum. Limit means where infinity will go. That means S infinity. S infinity means this series only. So limit n tends to infinity Sn is nothing but the sum of this series. Okay. So if limit of
Excuse me, sir.
yes.
Sir, I didn't get that, sir. Actually, how that limit of the series can be the sum of the whole series?
Limit of this Sn, see Sn will be this one, x1 to xn. If n tends to infinity, that the limit of this sequence Sn, then what will be this one, x1 plus x2 up to x infinity, and that is nothing but the series. Yes or no?
Yes, sir.
So that's why the limit of this Sn is nothing but the sum of the series. So the result is that if series is convergent, yes.
Sir, that is, sir, Sn is equal to the next n, na? When it's read from
Sn is
1 to
Sn,
infinity.
yes. So what is your doubt? Tell me.
Sir, Sn is the partial sum.
Yeah, Sn is the partial sum.
But when we put the limit from 1 to infinity, then that is equal to Sn, na? Xn.
Limit, yeah, Sn means from x1 to xn sum. This is x1 to xn sum. I'm saying limit n tends to infinity, that means n become infinity, that sum will go up to infinity, that is nothing but this series.
Oh, sir,
So that I'm
yes, sir,
saying.
I got it,
So so whenever you want to show that or prove that series is convergent, you just create a sequence Sn. If sequence is convergent, then you will say series is convergent. Then find the limit of the sequence. That will be the sum of that series. So what is the value of that sum? That is nothing but the limit of sequence Sn. So now I will do this example, that geometric series. What will be the sum? You know already what is the sum of this. So can anyone tell what is the sum if mod r is less than 1? And then we'll show by this sequence also what will be the sum. Can you tell me the sum of
A by 1
A
minus
by
r.
1 minus
by
r.
1
A
minus
by
r.
1 minus r.
A by 1
1
minus
minus
r.
yes. So now we'll do by this partial sum. So first I will calculate Sn. I will means create a sequence, and then I will find the limit of the sequence, and that will come a by 1 minus r only. So what is Sn? Sn will be the sum of first n terms of this series. So the first term, what is the first term of the series? It will come a. Second term is a times r. What will be the nth term?
AR per n minus
A into R to the power n.
AR to the power n minus 1.
N minus 1. So now can you sum this? What will be the sum of this? This is the GP series with the finite sum. What is the formula for the sum?
A into r raised to n minus 1 by r minus 1.
R
A
minus
into 1 minus r power n
1 minus r.
by 1 minus r.
Yeah, you just see here a mod of r is given less than 1. So accordingly choose the formula. So I'm writing
A by
a
r minus 1.
1 minus r to the power n divided by 1 minus r.
1 minus r.
Right?
1 minus r.
Yeah, 1 minus r. So this is the sequence. So Sn is the sequence. This sequence is given. So now can you tell me the limit of this Sn? What is the limit of this?
A by 1 minus r.
Yeah,
A by 1 minus r.
if you find the limit of this
A by 1
Sn,
minus r.
then you will get the sum of the series. So limit n tends to infinity of this sequence is a 1 minus r, because this r will give 0, because r is less than 1, r to the power infinity will give 0. So it is a times 1 divided by 1 minus r. So this is the limit. Is this sequence is convergent or not? Because it has a finite limit, it is convergent sequence. So the sequence is convergent, it has a limit also. So according to the definition, this series have the sum nothing but a 1 minus r. This is for GP series, you know, so you are able to tell the answer. Now we'll see some another example. The same method will apply. This series 1 upon n by n plus 1. If this series is convergent, that means what will be the sum of this series? If series have some finite sum, then definitely it is convergent. So again we'll find Sn. Once we'll get Sn, then we'll apply the limit and we'll get the sum of this series.
1.
Yeah, 1 is the correct answer, so we'll do that one. So what will be the Sn? The first term, what will be the first term?
1 by 2.
1 by 2.
1 by 2.
1 by 2. Second term?
1 by
1 by 6.
1 by 6.
Yeah, 1 by 2 into 3.
1 by 6.
Third term 1 by 3 into 4. And nth term 1 by n into n plus 1. So now we have to do the sum. So the first term we can write 1 minus half. Second term is half minus 1 by 3. and the last term is 1 upon n minus 1 upon n plus 1. So what will be the sum?
1 minus 1 upon n by plus 1.
Yeah, 1 minus 1 upon
1
n
minus 1
n
by
plus
n.
1.
So this is the value of Sn. So what is the limit of Sn? Like n tends to
1.
infinity?
1.
1. So this series is convergent and it will converging to the limit. That means the sum of the series is 1. Now one more example. It is written this series is not convergent. So what we'll do, we'll calculate Sn. If Sn is not convergent, then this series is also not convergent. It is written 1 minus 1 plus 1 minus 1. So can anyone tell what will be the value of Sn?
No, sir.
1 by 2.
Sir, its summation is 1 by 2.
This summation is 1 by 2, you are saying?
Yes, sir.
So we don't know the last term, no?
0 or 1, sir.
No, sir, we
Sir, it is
can.
infinite GP.
Sir, it's
So it can be 0, 1 or minus 1.
Is equal to 0 if n is even.
Yes. So suppose you have some difficulty, then I will do like this. What is S1? S1 can you tell? The
1,
first
sir.
term. 1.
1.
What is S2? S2 will be x1 plus
0.
x2. What is
0.
what is
0.
S2? It is 0.
0.
What is
Zero.
S3? S3.
Minus 1.
Minus
No.
Minus 1.
No.
Minus 1.
No.
1.
S3.
1, 1.
Sorry, 1.
Only 1.
Yeah. S4 is 0. Then
0.
S5 will also come 1 and so on. So this is the sequence like this. 1. Then second term is 0, 1, 0, 1, 0. This sequence is convergent.
No, sir.
No.
No,
No.
sir.
No,
No.
sir.
So that's why it is written this series is also not convergent, because that Sn is not convergent according to the definition. So this series is also not convergent. Okay. If sequence will converge, then series will also converge. And if it is convergent, you will find the limit, you will get the sum of that series. But it is not convergent, so we cannot find the sum also. This is the sum of series or convergent of the series or divergent of the series by using the actual definition. Okay. Now we'll see some result that is applicable in the series. If you have two series like summation xn and another one is summation yn, and both are convergent. If it is divergent, then the result whatever written in the part A, it is not correct. If there are two convergent sequence, then you can add them, and addition is nothing but the sum of those values. That is only applicable in the convergent series. So whatever example I given to you, that ln2, that is not working because of this result is violating there. And if you multiply by any scalar in the convergent series, then answer will also multiply by alpha. Similarly, if it is even negative, the term of all terms are negative, then if you subtract also, then answer will come as x minus y. So two convergent series, that sum if series is convergent, if you multiply by any alpha, that product will also converge, and it will converge to the number alpha into x. So
Sir, these properties are valid if these two the sequences are convergent.
yeah, if it is convergent, then only it is valid.
Means it is the only case
If it is
if
divergent,
it is convergent.
yeah, if it is convergent. See, it is given that this series is convergent, then only this property will valid. If it is not convergent, we cannot say that. That means two divergent series, if you do the sum, it may converge, it may not converge. We don't know anything. But if their series is convergent, sum will be definite. Sum must be convergent. And if you multiply by any scalar, that will also converge. So to
So
check
sir,
series,
that's the mistake you did there.
yeah, that is the mistake I did. I will explain where I did that mistake. Okay.
Yes, sir.
So see that if you want to prove that series is convergent or divergent, then you have to take the partial sum, you have to construct a sequence, find the limit, then only you will get the answer. But that is not a good idea, or that is not an easy technique to apply for all type of series. So there are some alternative method or technique which you can easily apply to solve the problems. Okay, so this is the one monotone criteria for the sequence, the same, the analog of that in case of the series. So what monotone criteria for that sequence is either increasing, and if it is increasing bounded above, then it is sorry, if it is increasing bounded below, it will converge. If it is decreasing and bounded, then it will converge. So the same criteria in terms of the series. So here it is written, suppose series of non-negative term is convergent if and only if the sequence is bounded. If sequence is bounded, then it will converge. Sorry, this series will converge. So what is the value of S1? That is the first term in the series, it is X1. What is the value of X2? Sorry, S2, it is X1 plus X2.
X1
So
plus
these are the terms of the series. But here one additional condition is given, it is non-negative. That means all the terms in this series x1, x2, this is non-negative terms. Like x1 cannot be negative, x2 also cannot be. It can be 0, but it cannot be negative. So because of this property, can we say that S2 is always bigger or equal to S1, S2, S3 and so on?
Yes, sir.
So this sequence is
Yes, sir.
increasing or decreasing?
Increasing.
Increasing.
And it is saying that increasing, yeah, it is increasing sequence because S2 is bigger than S1, so it is non-negative, it is written. If it is 0, then it is equal to S1 equal to S2. Suppose X2 value is 0, then X1 and X1 plus 0 is X1 only, then equality can hold. So this sequence is an increasing sequence because it is given non-negative terms. Suppose the series is alternate form like plus minus, then this result will not work. Okay, for that you need a series which have all terms either positive or 0, then only you can apply this criteria. Okay, so this is increasing, and suppose it is bounded, so it is given that in this result it is written that the sequence of non-negative term, that implies that series is the sequence Sn is increasing. And now if it is bounded above, so definitely it will converge from the sequence criteria. So that's why for this series will also converge. So like this example, is this series is convergent or not? So first, what is the S1, S2, S3? So it is increasing because 1 by n square is always positive. So whatever S2 will come, it will be bigger than S1. S3 will be bigger than, so I'm just writing here S1 equal to 1. S2 will give 1 upon 2 square. S3 will be, 1 plus 1 upon 2 square. S3 will be 1 plus 1 upon 2 square plus 1 upon 3 square. So clearly it is strictly increasing. So this is the increasing sequence. Now if we are able to prove that it is bounded above, then we will claim that this series is convergent or that sequence is convergent. So now we have to show that it is bounded. That means Sn is bounded. What is the value of Sn? So we'll find Sn. Sn is nothing but x1, x2 and so on xn. So the first term is 1, second term is 1 plus 2 square, 2 square, then 3 square and 1 upon n square. So is this sum is bounded or not? So can anyone give me any idea how to do? Now we have to show that. So
Sn minus Sn plus 1.
So now what I will do, this is nothing but summation. The first term is 1, k from 2 to n, 1 upon k square. Can I write like this? I'm just showing this example only. If suppose this question will come, there are other method will also discuss, that is easy to do. So we'll apply this. So for this method only I'm showing this example. So now this k will start from 2 to n. Can we say that it is less than, because we need some bound k from 2 to n, 1 upon k into k minus 1. Can I write this? So there are 2k, k into k. 1k I replace by k minus 1. And I'm saying this side is bigger. Yes or no?
Yes, sir.
Here you are
Yes, sir.
here you are dividing by k minus 1 and k is running from 2. That's why I separated 1, because if 1 is there, then 1 minus 1 will become 0. That's why this one term is separated from this summation. And the summation of this is very easy. Can you do the sum? I already did. Can you do the sum? It is the telescopic series.
Yes, sir.
Yes, sir.
Yes, sir.
We will
Obviously.
separate it.
Yes, sir.
Yeah, we already have this one as an example here. This one, n into n plus 1, then what will be the sum? It is same as k into k minus 1. That means, so what is the sum of this?
1.
This, yeah, 1.
1.
You can do 1 upon
1.
k minus 1 upon k minus, so it is 1 plus 1. So this Sn is always less or equal to 1 plus 1, that is 2, so it is bounded. That means all the terms of the sequence is less than 2. So it is increasing sequence bounded above, so this sequence will converge. That means 1 upon n square is convergent sequence. So is it clear? So till now, whatever I am showing, whatever established in the sequence, the same alternate or analog in the form of the series. But in exam, if some question will come, definitely we will not going to apply such result. These are just basic. We'll get some advanced method which is easy to apply. We'll get the convergent and type. So here by this monotone criteria, series 1 upon n square and from 1 to infinity is convergent. Now next one is the Cauchy criteria. So if you remember the Cauchy criteria for sequence, what is the Cauchy criteria of sequence?
Sir.
Yes.
xm
Sir,
minus
in the
x.
monotonic criterion, bounded
Yes.
above is necessary. Above what?
Yeah, if it is increasing, then above is necessary. If it is decreasing, then below is necessary.
Yes.
But it is positive term, it will always increasing only. So above is required.
Sir.
So this is the same criteria for sequence in the Cauchy. Xm minus xn mod is less than epsilon for all m and bigger than. So everything is same. The only difference is that here it is xm minus xn in terms of sequence. So when, according to the Cauchy criteria, when you will say this sequence Sn is convergent, according to the Cauchy criteria, if you have Sm minus Sn mod is less than epsilon, this is the Cauchy criteria for the sequence I am writing. So here epsilon is the positive quantity. This is true for all m and n bigger than n naught. So there exists n0, that n0 we have to find belongs to natural number such that this property will satisfy. This is the criteria for sequence. Now just replace the value of Sn and Sm, you will get the criteria for series. Like what is the value of Sm? If m is greater than n, here we assume it is the sum of x1 to xm and xn is the sum of x1 to xn. So what are the remaining term in this? Sm minus Sn. Like this is first m term sum, this
n
is
plus
first
1
n
to
term sum. So it will start from n
Sn
plus
plus 1
1,
to Sn.
it will go up to m. Right, so this is the Cauchy criteria. So instead of this condition Sm minus Sn for the sequence Sn, it will become xn plus 1 to xm. If this sum is less than epsilon, for there exists some natural number, then you will say that it is satisfying Cauchy criteria. That means sequence is Cauchy, then it will convergent. Then that means the series will also converge. So in the next class, I will do one example, that is summation 1 by n for this Cauchy criteria. Okay, if in exam, if it is not mentioned, you have to apply Cauchy, then you will never apply Cauchy, monotone criteria, even the partial sum definition, if it is not mentioned. If it is mentioned, then you have to do only by this method. If it is not mentioned, then we will have some test like a root test, ratio test. Those tests will apply to check series is convergent or divergent. but those test proof also came from this actual definition only. So that we will discuss in the next class.